Hi, I'm Maria from RedShiftBio. RedShiftBio is an energetic company based in the greater Boston area. What? It doesn't look like Boston? You're right, I'm in California, the Redwood Shores to be specific. It's near San Francisco and it's where our West Coast lab is located. I know, it's so beautiful and it's so beautiful all year round. So let's hike along the shoreline. But before that, shall we do some experiments together? We have something very exciting today. After that, let's bike. I promise. So make sure you stick to the end of the video. Let me first introduce you to MMS, which stands for Microfluidic Modulation Spectroscopy. It measures previously undetectable structure changes in biomolecules. You may skip this if you're already familiar with MMS. So why do our current customers use MMS? What values does MMS bring to them? So first, it measures a dynamic range of concentration from zero point 0 to 200 mg per ml. And second, it allows you to measure the biomolecules in the formulation of interest, so no need for dilutions anymore. And third, it's fully automated from measurement to analysis so that we're reducing the human error to the minimum. And fourth, it's up to 30 times more sensitive than traditional comparable technologies like FTIR or CD. So in fact, our first generation instrument using MMS, which is the AQS3 Pro, has been quickly adopted worldwide by large biopharma companies, major CROs, and CDMOs. And we also have a growing list of peer-reviewed publications. Now, we have just launched our second generation MMS instrument, Apollo, is significantly faster, consumes much less volume, and has higher resolution. Let's dive into the details. So now I'm going to prepare 5 different protein samples. Lyse them at 2 mg per ml, BSA at 100 mg per ml, BSA at 10 mg per ml, and IgG at 2 mg per ml, and finally alpha chymotrypsin at 2 mg per ml. So we're going to take triplicates for each sample on both the first generation AQS3 Pro and the second generation Apollo. So, and compare them too. So let's go. All right. So here, let us first look at the comparability between Apollo and AQS3 Pro to ensure you that we still have the same data quality. This figure shows that the similarity plots are well overlaid between Apollo and AQS3 Pro, while some differences are noticeable due to their high resolution of Apollo. For all 5 different samples, similarity score via area of overlap, or AO, are equivalent and ranged from 99.2% to 99.9% in all samples tested, with the higher concentration sample having a higher similarity score. This surpasses our system specification of 98% for similarity between replicates. In addition to quantifying the overall structure, our software is also capable of determining the higher order structure compositions by performing Gaussian curve fitting on the similarity plots. The figures here show that the percentages of each HOS, or higher order structure, motif characterized by Apollo and AQS3 Pro. We have more detailed data in our app note, where you can find that the HOS results between Apollo and AQS3 Pro do not differ by more than 1%. Now that we have ensured the same data quality, let's look at what we have improved on Apollo with some experimental data. The number 1 improvement is the significant amount of volume and time it now saves. Here, we have quantified the percent volume and time saving on Apollo as compared to AQS3 Pro. Across all 12 pairs of samples we tested on different units, Apollo demonstrates a 32%, 45%, and 51% reduction in volume for 1 replicate, 2 replicates, and 3 replicates, respectively.
And similarly for time, Apollo has 25%, 37%, and 47% reduction in time for 1 replicate, 2 replicates, and 3 replicates respectively. Next, let me demonstrate how we can optimize our protocols to achieve the best combination of precision and volume consumption. So basically, a higher volume and a longer time consumption can usually achieve a greater precision. On the other hand, if we don't need ultra high precision, we may save more sample volume and time. Here in this figure, the x-axis shows the number of coads, which means the number of data points used for data averaging at each wave number. The y-axis on the left, corresponding to the bars in red, shows volume consumption, whereas the y-axis on the right, corresponding to the blue lines, shows the repeatability. We see that both the volume consumption and the repeatability generally go up with more coads. However, not in a linear pattern. In this table on the right side, we see that the best repeatability volume trade-off is found to be at coads 8. Here, from coads 4 to coads 8, repeatability increased from 97.9% to 99.1%. For cases where low concentration is used, or the highest repeatability is appreciated, using 32 coads can help boost the repeatability to 99.5% for a 2 mg per ml lysosome sample. But please note that the volume consumption is sample dependent and varies from sample to sample. Therefore, the volume consumptions reported here do not guarantee enough volume in other experiments. The third major improvement is the increased throughput enabled by the addition of a buffer station inside the instrument. Now we can measure up to 47 samples in the same 96 well plate as compared to 23 on AQS3 Pro. So here we have an example layout bearing the maximum number of samples on one plate. Last but not least, Apollo has enabled structural data collection in single wave number increments on the right side, as opposed to 4 wave number spacing on the left, with an exception of certain keep-out regions where there are strong water vapor absorption, as shown in this figure. This greater resolution will allow the detection of more subtle spectral changes. So finally, in summary, here we have demonstrated that our second generation MMS instrument, Apollo, is proven to carry the same level of precision with the following major improvements. Number one, around 50% reduction in both volume and time consumption with customizable precision. And number two, maximum throughput on one plate doubled. And number three, the single wave number increment enables a high resolution. And number four, the wash station upgrade for more efficient system cleaning. And finally, many requested features by existing users have been incorporated into our new Delta software.
And now let's bike along the shoreline. Ooh. Thanks for sticking to the end of the video. Please give us a thumbs up.